Now let's talk titrations. In this first portion of this section, we'll just do a brief introduction and overview of what we're going to go over in the next series of presentations. In this series of presentations, what we're going to do is study the titration of a weak acid with a strong base. We're going to begin with 50 milliliters of 1 molar acetic acid, and we're going to titrate it with 1 molar sodium hydroxide, meaning that we're going to add incrementally larger amounts of 1 molar sodium hydroxide until we react all of the acetic acid away. Now, I want you to think about what the net ionic equation will be for the chemical reaction that occurs during the titration as you add the sodium hydroxide. Here are some options for potential net ionic equations, and think over what the equation would be and put in your answer. All right, having given you a chance to put in your answer on this, let's talk about what the correct answer will be and how you get it. To find the net ionic equation for an acid-base reaction, it's crucial that you begin by writing the list of major species that are present in your solution, because that's how you're able to determine what all of the players are in this game that you have going on in your solution. So that's where we'll begin. Write the list of major species. We have acetic acid, which is a weak acid, and so it does not exist in the form of H plus and acetate ion to a great extent. The vast majority of it exists in the form of CH3COOH. That's the major species. To this, you're adding sodium hydroxide, which is a strong base, and so that should be dissociated into Na plus and the hydroxide ion, and then water is always present as a major species. Now, we go through the list of major species, and we react the strongest acid with the strongest base. The strongest base that we have here is the hydroxide ion, and the strongest of the acids that you have here is the acetic acid, so they will react with one another to completion, according to the following equation. CH3COOH reacts with the hydroxide ion to completion to produce the acetate ion and water. This is the net ionic equation for the reaction that occurs here. Because we do not dissociate the acetic acid to a great extent, you have to keep it together in that form. So our answer here is, it looks like B. Now, having written this reaction, that's going to be very important for us in solving some problems that we're going to deal with involving this titration. Over the next series of videos, what we're going to do is study this titration of 50 milliliters of 1 molar acetic acid with 1 molar sodium hydroxide, and we'll calculate the pH of the resulting mixture at 4 different points along the way during the titration. We'll calculate the pH before adding any sodium hydroxide. We'll calculate the pH after you add 10 milliliters of sodium hydroxide. We'll calculate the pH after adding 25 milliliters of sodium hydroxide. And then lastly, we'll calculate the pH after adding 50 milliliters of the sodium hydroxide. And along the way, we're going to get a lot of practice with acid-base chemistry and doing pH calculations. This will involve combining concepts that you've learned all throughout this quarter so far, and even some things that you saw back in Chem 1A. So in our next video, we'll take a look at the first point on our pH curve before we added any sodium hydroxide.